Welcome to the channel. Our today's topic is mirror formula. Students, before deriving mirror formula, first we talk about some special rays. These are the rays that we use for geometrical construction of image formed by a spherical mirror. Let us consider an object O is placed in front of a concave mirror where the mirror will form its image. For this purpose, we take three rays coming from the top of the object. Ray number 1, that is coming parallel to the principal axis. When this ray is reflected from the mirror, it always passes from principal focus. We call it ray number 1. And second ray, that is coming from the object and falling on the pole, making certain angle with the principal axis. According to the law of reflection, after reflection, it will make same angle with the principal axis. So it is ray number 2. And ray number 3 is one that is coming from the focus and falling on the mirror. After reflection, this ray becomes parallel to the principal axis. And where these three rays meet after reflection, there the image is formed. So any two or these all three rays are used for geometrical construction of image. Now students, let us start the mirror formula. Students, look, an object of height AB is placed in front of a concave mirror using two special rays. Ray number 1 coming parallel to the principal axis. After reflection, this ray will pass from principal focus. And ray number 2, that is falling on the pole. After reflection, it will meet that first ray. Here they meet with each other. Their image A prime B prime is formed. Students, from the diagram, there are two triangles. One is PAB and second is PA prime B prime. These two triangles are similar, so we will consider these two triangles, and the ratio of their two sides is always equal to the ratio of their two other sides. So considering triangle APB and triangle A prime B prime, ratio of their two perpendiculars AB over A prime B prime, this side and this side, ratio of these two sides is equal to the ratio of two other sides, that is BP base of first triangle over B prime P base of second triangle. So these two ratios will be same because triangles are similar. Similarly, there are two other triangles FXP and FA prime B prime. These two are also similar. So taking the ratio of two sides, that is XP over A prime B prime. Now look at diagram. The distance XP is equals to the distance AB, being the distances between two parallel lines. So either we can write XP or we can write AB. So here I write AB over A prime B prime equal to FP, this distance, this side of this triangle, over B prime F, this side of the second triangle. So ratio of these two sides is equal to ratio of the other two sides. Now comparing these two equations, since their left hand sides are equal, therefore their right hand side should be equal. And we get right hand side of first is equal to right hand side of the second. So BP over B prime P is equals to FP over B prime F. Now look at the diagram. The distance B prime F is having no specific name. So we replace this distance with another combination of two distances. What is that? We represent this distance by the difference of two distances. Look at the diagram. This distance B prime F can be obtained by subtracting FP, this distance, minus this bigger distance. So when FP is subtracted from PB prime, we get this B prime F. So replacing B prime F with this value, we get equation like this. BP over B prime P is equals to FP over PB prime minus FP. Now students, these lengths are having specific names. What are these names? PP is actually the distance of object and I represent it with P. In some books, it is also represented with U or any other letter. So, however, here I represent it with P, distance of object. FP is the focal length. I represent it with F. Similarly, PB prime is the distance of image. I represent it with Q. So after these representations, the equation gets this form. P over Q is equal to F over Q minus F. Here I look at this equation. I cross multiply it. By cross multiplication, I get this equation. To solve it, I divide both sides with PQF. Dividing by PQF. This first term is divided with PQF, second is divided, third is divided. Now what happened? P and Q in the first term will be cancelled, P and F in the second will be cancelled, Q and F in the third will be cancelled. So these terms are cancelled. What we are left is 1 over F minus 1 over Q is equals to 1 over P. Rearranging this equation to get the standard form of mirror formula. 1 over F equals to 1 over P plus 1 over Q. Students, F is the focal length, and if mirror is convex, focal length is negative. If mirror is concave, focal length is taken positive when inserting the values to solve a numerical problem. Similarly, if object is real, P is positive. If object is virtual, P will be negative. Q is positive for real object, real images, and Q is negative for virtual image. A virtual image is one that we cannot obtain on the screen, where the actually rays of light do not meet. However, they are appearing to be meet there. So the image is virtual, and for virtual image we take value of Q negative. Student, this is how we derive mirror formula. I hope it is clear. Thank you for sparing your time to watch the video. If you liked it, don't forget to subscribe the channel. Take care of you. Goodbye.